Okay, now we're going to have a lesson on atoms. And understanding atoms is fundamental to understanding electricity. Down at the atomic level is where electricity actually operates, and we're going to get into why that is in just a moment here. But let's study atoms. We have some objectives here. First, we want at the end of this lesson to be able to define what an atom is. We want to list the components within an atom. We want to understand the relationship between the components of an atom. And we want to specifically understand what makes electrons unique within an atom. Okay, so let's get started here. First, before we talk about atoms, we need to talk about elements. Okay, elements, all matter is made up of elements. Okay, so you can take anything and you can break it down into individual elements. Elements are just substances that cannot be broken down any farther, in this case by any chemical means. Here's our periodic table of elements. You might have had chemistry, and just putting this on the slide may be a little intimidating to you. Please don't get intimidated. We're only going to be talking about atoms in the atomic level. In this case, we're going to focus on copper. Copper is what most wiring is made of. There are some that are made of aluminum, but copper is by far our current carrying conductor of choice, and we'll be discussing that a little bit further as we learn about atoms. So let's get into this. Atoms are the smallest particle of an element that retains that element's properties. So if we talk about copper, copper is an element. Okay, so I could have a hunk of copper, like in a piece of wire, but if I broke that down into its smallest particle, that would be an atom. Okay, and that atom would contain everything that still makes it copper. Okay, and that's going to be a little clearer when we talk about the components of an atom here in just a moment. So first, when we look at an atom, we have this nucleus here, and I'm showing a nucleus here, and in this case it has some blue and red spheres in the middle, and it's a densely packed center of an atom. That nucleus is comprised of both protons and neutrons, okay, and they are held together tightly and in the center of this atom. The neutrons have no charge at all, and therefore they're called neutral. That's kind of where they get their name from, is neutron. Okay, so they are a part of the nucleus, but they are not a part of the charge within the atom. They are neutral in charge. The protons, on the other hand, protons are positive in charge. The number of protons in an element will determine its physical properties. So we have, in copper's case, we have so many protons in that nucleus, and because we have that quantity of protons in that nucleus, that makes it a copper atom, and we're going to look into that a little bit more. Copper has 29 protons. So the number of protons in an atom determine its atomic number. Copper's atomic number is 29 because it has 29 protons. No other element on the periodic table of elements has 29 protons. If we were able to, we're not, but if we were able to take an atom and change the number of protons to 29, we would actually be converting it from whatever it is to copper, because copper has 29 protons. And when we look at that table of elements, there's several things of information here. In this case, we are spelling out the word copper. It's abbreviated Cu, but up here in the left-hand corner is going to be the atomic number, and that is copper's atomic number, which is 29, and that 29 is the number of protons that are within that atom. And that number remains constant. So that's not going to change if, like I said, if we were able to, change that from 29 to 28, we would literally be changing it from copper to some other element. We would have to look on the periodic table to see what element it would change to. But because it has 29 protons, it will be copper. And as long as it's copper, it's going to have 29 protons. No two elements have the same number of protons. I think I've covered that. So 29 protons means copper. Let's talk about electrons. Electrons are different. They are orbitals. And they're shown here in this graphic. This black line going around is showing the path that this black sphere is taking. They're flying around the outside of that nucleus made of protons and neutrons, much like the Earth revolves around the sun. Electrons are extremely fast. They're flying around so quickly that if you would take a picture of it, it would just be a blur. So electrons orbit around the nucleus. Electrons are negative in charge. Okay? Remember, protons are positive in charge, and we'll learn a little bit more in the future when we study Coulomb, but he discovered that what we know now as opposites attract and like charges repel one another. So these are opposite in charge. A proton and an electron are opposite in charge. One's positive and one's negative. And it's that mutual attraction is what keeps the electron from just flying away into the atmosphere. It is orbiting around that because it is attracted to the nucleus because of the proton's positive charge. Much like the sun has a gravitational pull on the Earth, and that's why the Earth is orbiting around the sun and we don't fly off into space as well. Electrons and protons are attracted to one another, like I was stating. An atom usually has the same number of protons and electrons. And I want to be clear. I use the word usually here. If we have a stable atom, we should have 29. Well, we will have 29 protons. We should have 29 electrons. Okay. Electricity has a little bit something to do with maybe that not always being the case, and that's why I had to use the word usually there. So in this case, if this is a stable copper atom, we would have 29 protons and it would have 29 electrons, and it would be in balance with one another. So I'm stating it there. Copper has 29 protons, 29 electrons. Individual atoms can lose or gain electrons, and that is where electricity comes into play, and other things. But that's where, when we study electricity, we're actually going to be studying this phenomenon of electrons being able to be lost and gained by atoms. So, in review, let's define an atom. What is an atom? I want you to think about that for a minute. Maybe pause the video, and then we'll come back. An atom is the smallest particle of an element that still retains the element's properties. So, like I said, if I had a hunk of copper and I filed away at that copper and I kept breaking it down until I got to the absolute smallest particle that I could get to, it would be an atom. And that atom would still retain those properties of copper, and what that means is it would still have 29 protons, and if it was stable, it would have 29 electrons as well. Let's list the components within an atom. Okay, go ahead and pause the video again and see if you can say it in your head or write it down on a piece of paper, and then come back to the video and we'll go over that. Okay, neutrons. They're in the nucleus and they're neutral in charge. Protons, they're in the nucleus as well. They're tightly bound to our neutrons, and they are positive in charge. And then we have electrons. And electrons are negative in charge. They're orbitals. They are flying around that nucleus, that tight nucleus, much like the Earth flies around the sun. And those are all the components of an atom. There's no more components than that to an atom. So it's just those three components make up an atom. And because we have, in our case, what we're talking about is 29 positive protons, and if it's stable, 29 negative electrons, we have a copper atom. And understanding the relationship between the components of an atom, protons and neutrons make up the nucleus. I think we stated that just a minute ago. But those two components make up a tight bond that is fixed within the center of the atom. And the protons, the number of protons, determine, and this is very important, the number of protons determine what type of atom it is, what element that atom represents. Okay? So again, if we have 29 protons, we're talking about copper. We're not talking about any other element. Electrons orbit around the nucleus. Okay? So they are definitely mobile. Protons and neutrons, that nucleus actually does rotate around a little bit, but it is fairly stable in there compared to an electron, which is very active. And an atom usually, and I underline usually, has the same number of protons and electrons. When we get into current flow and things, we're going to talk about how electrons are shared between atoms and how that makes electricity possible. But before we can get to that, we just need to understand what is going on in the atomic level here. So I hope that is helpful. That is the lesson. Now, one thing that I wanted to highlight here at the end is what makes electrons unique. And what makes electrons unique is they can be shared between the atoms. Okay, and this is kind of be the precursor for us talking about current flow and what happens there. So that's kind of a teaser for the next lesson. Electrons can be shared between atoms, and because of that, that makes electricity possible. So look forward to future lessons on how we're going to take this lesson and build upon it to understand electricity. We'll see you then.